Hello, everyone. How are you doing? I hope you're having a great conference here. I'm so happy to be back at DevOps UK again. Today I'm going to talk about developer experience with Java on Kubernetes. So thanks a lot for joining. I'm Thomas. I work at Systematic. It's a Danish software company. I'm a software engineer and cloud architect, really passionate about anything Java and Cloud Native. I combined all these passions and wrote a book recently. It's called Cloud Native Spring in Action with Spring Boot and Kubernetes. And I'm really a big supporter of open source technologies and try to contribute as much as I can to different projects, both in the Java space and in the Cloud Native ecosystem. Now, before talking about technologies, I want to ask a question. Why do we build software? I know there might be a lot of different answers, complicated questions, but if we really think about it, most of the times we build software because we identify the problem, and we realize that we can use software to solve that problem. So it all starts with a problem. We know it makes sense to use software to solve it. We implement a solution for that problem using software. And in the end, we provide value. We deliver value to the end users of our software, to our customers, and to our business. That's why we build software. So the way that we deliver value is actually really, really important. It all starts with an idea. We identify this problem. We have an idea about how to solve it. At some point, we involve developers to implement that solution. Once they are done, they go through what we call the path to production. Now, today, I'm going to consider production a Kubernetes environment. So all these activities that we go through before reaching production are really important, because if our software doesn't reach production, it's useless. So the way that we go all the way to production, it's really critical to the success of our business, to the success of our software product. So today, I want to look at the developer perspective around this path to production. So all the initial activities that developers usually do, and how will that interact with Kubernetes. So let's talk about developer experience. I know it might seem very buzzwordy. Everyone is talking about developer experience, but actually it's nothing new. It's not a new concept. I really like the definition in this paper published by two engineers at the University of Helsinki back in 2016. They say that developer experience could be defined as a means for capturing how developers think and feel about their activities within their working environment. But the important question is, why do we even care about developer experience? Why are we talking about it? And the reason is that we have an assumption that the improvement of the developer experience has positive impacts on characteristics such as sustained team and project performance. So we care about developer experience because having a good experience means that developers can work in a more effective and efficient environment. They are more productive, they are happier, they feel better in their daily job, and ultimately, the big benefit that we get by caring about developer experience, once again, value. So we talk about developer experience because improving the developer experience improves the value that we deliver, and the value is the reason why we build software. So at this point, let's start looking at some baseline. We are working with Java applications. How would a modern workflow look like? And right away, I jumped into technologies. That's very common, right? Oh, we're talking about Java. I can use Kubernetes. I have all these amazing tools. I have the Cloud Native landscape. But it's not all about tools. Actually, focusing just on tools probably will lead to failure ultimately. Because, of course, tools are important. We are technologists. We really love our tools. But if we have the right tools, but we don't have the right processes supporting those tools, then things will not work. And not just that, we also need the right organization around this technology and processes, the right mindset in the people working. And this is overall what we call a culture. So developer experience is ultimately about culture. And this model, I really like it because it's not applying just to developer experience, but if you think about it, it can apply to a lot of things that, let's say, microservices. Oh, amazing, we have all these technologies to do microservices. Let's do it. Now, from tomorrow, we're going to do microservices. But then we're not changing our processes. We don't even know what continuous delivery, continuous integration is. The organization is still not wrapped around the mindset of having small teams working on applications independently, and ultimately, microservices will not work. Doesn't mean that microservices is a bad architecture. No, it's just that we used it wrong. And security is another example. We might have great security technology, but if we don't have the right mindset in people, if there's still that person that clicked on a ransomware link and then affect the whole company IT network, we might have even the best technology, but if we don't have all three of these components together, things will not work. So, again, tools are important, and today I'm going to talk about tools, but please remember, tools are not enough. If we talk about organization, I can recommend the Team Topologies book. It's really great at identifying how teams can collaborate with each other and how to share or actually split responsibilities, so to have clear responsibilities assigned to different teams and work together towards the same goal. And around processes, well, we have great processes already in our industry. We have continuous delivery, which is the best way we know to build better software faster. Just to quote Dave Farley, we have other amazing books. I'm not going to talk about those today, but just want to be clear that just having tools is not enough. Now, assuming we take care elsewhere about processes and organization, what can we do about technology? So let's focus now on the developer workflow, and then let's try to have 3 goals in mind in our analysis about how we can improve the developer experience on Kubernetes. The first goal we want to achieve is a rapid and continuous feedback loop. The second goal is a reduced cognitive load, and the third goal is a clear and safe path to production. So let's get started with our development workflow. Now, building modern Java applications, we go through the same process, actually 2 steps. The first step is bootstrapping a project, and the second step is starting a local development loop. So, for example, I can build a new Spring Boot application, I can add my web dependency to build a web application, and then I add Spring Boot DevTools in order to establish that live reload loop while I'm working locally. I have already created a very small application. I have 2 endpoints, a root endpoint and a books endpoint, returning some books. I'm using Java 20. The domain object is a record. So let me start the application, and this will be our baseline. So just pure Java, without any other technology based on Kubernetes. So the application is running. Let's give it a try and see if it's working. All right, what about the books endpoint? And it's working too. So now I can go ahead and make some changes. Let's add a new book. Maybe the Silmarillion, like that. And if I call the endpoint again, my application is reloading in the background, so I have the endpoint reloaded. And this is quite common across different frameworks. With Quarkus, you can even establish this for testing and have continuous testing, which is really, really cool. And overall, it's a very good developer experience, right? And if we compare it with the past, we can identify some changes into how we build Java application. We talk about Cloud Native. Cloud Native is more about architecture than about where we deploy the application. So compared to a more traditional architecture, in the past we had the runtime, Java, JVM. We had some middleware, an application server or a web server deployed on top of the JVM. And then our application ultimately would be packaged as a WAR file or EAR file. Now, instead, what we do is we have the runtime, but then the application is self-contained. So we have an executable Java application packaged as a jar file. We can run it directly on the JVM, and we don't have any other dependency to run that application. If we consider our initial goals, the feedback loop in the first case was quite slow back in the days. And now it's quite fast, so we went from minutes to seconds. And if we even add GraalVM to the mix, we even get to milliseconds. So it's an impressive improvement there. And then if we consider the cognitive load, we needed to know a lot of different things. Now the cognitive load is quite low. And that's our baseline. Cloud native applications, self-contained, reduced cognitive load, and fast feedback loop. But now starts the problem here, because we need containers. We want to get to Kubernetes, we need to containerize the application. And now suddenly things are not that clean and simple as they used to be. Because we're not working with Java runtime directly anymore. We have a container runtime, like Docker, like Podman. And on top of that, we need to package the application as a container. So we have an additional step, which makes the feedback loop a bit slower. And the cognitive load is a bit higher, because now we have to know how to containerize the application. The simple way is writing a Docker file. Docker file adds cognitive load. It's very simple to write a Docker file, but writing a Docker file which is ready for production is really not that simple. So let's try to address that problem before moving to Kubernetes. There are different tools that can help us containerize applications without writing Docker files. And ultimately, it's a matter of who is responsible for what. As a developer, I'd prefer working on my application rather than maintaining a Docker file and making sure that it's properly secure, patched, that it's properly performant. And I can use a tool like Cloud Native Buildpacks. Cloud Native Buildpacks is a specification by itself that defines how we can transform application source code into a container image. And the great thing about it is that it's a polyglot tool. So not only you can use it across different Java frameworks, but even across different languages. So you can use it with Spring Boot, with Quarkus, but also you can use it with Golang, you can use it with .NET, you can use it with Python, Ruby. It's really a great tool. And then with one command, like running pack build, we point it to the source code, and we obtain a container image. And the cool thing in the Java environment is that the frameworks that have this support for build packs, like Quarkus or Spring Boot, they even have out-of-the-box integration with Cloud Native Buildpacks. So you can directly use the framework CLI or the Gradle and Maven plugin in order to use Cloud Native Buildpacks. And we don't have to install anything extra. So if we consider this same example, I'm using Spring Boot, so I can run from Gradle, a boot build image task. And this will build a new container image, which is ready for production. And then, just to verify that it's working, let me run it, book service. Oh, I have to stop the application from before and run the container. Let's verify that it's working. And it's working. Perfect. So it's one less thing that I need to do as a developer. I can use this tool in order to obtain a container image directly. Nice. But now it's not enough. We have a container, and suddenly we need to introduce Kubernetes. So what happens now? We still have a container runtime. But now on top of that, it's back. We have the middleware. Kubernetes is now right there, and on top of Kubernetes, then we can ultimately deploy our application. And now all the work that we've done over the years to improve the developer experience, now we have, once again, a very slow feedback loop, because we have to containerize the application, we have to configure Kubernetes, we have to deploy the application there. And even worse, the cognitive load got even higher than at the beginning of our story. So something looks sketchy there, right? Like, why are we even talking about Kubernetes if it's that bad? Well, let me tell you two important things here. The first one is, I assume in these examples, in this presentation, that it makes sense to use Kubernetes. Like, it's really important that we don't use Kubernetes just because it's hyped. Kubernetes solves a set of problems. If we have those problems, great, we can use Kubernetes. But if we don't have those problems, maybe it's not a good idea to use Kubernetes just because it's so popular, because then it would end up having too much complexity that we don't really need. So the first thing is making sure that we really need Kubernetes. And the second thing is what actually a lot of the times leads to this situation, which is, oh, now we have Kubernetes, let's just throw Kubernetes and all this cloud native stuff to developers. And that means that developers now need to know about all these different tools. They are responsible for it, have a lot of cognitive load, and things don't work quite well anymore. So we need to improve the situation. We cannot just say, dear developer, here's your Kubernetes, just do the rest yourself. We need something more. It's not a good developer experience, also because Kubernetes was never meant to be used by developers directly. It was meant to build services on top of it that ultimately are used by developers, but not directly. So what can we do? Because Now, if we want to deploy an application, we need to define all these configuration manifests. There's a lot of YAML everywhere. We need a deployment to configure how to deploy the application. We need a service to expose the application inside the cluster. And that's not enough because we cannot use it. We need an ingress to expose it outside the cluster. So we start by writing all these YAML files. And then we can maybe look for some tools that can automate that process as well. For example, a great tool in the Java ecosystem is JCube. It supports a lot of different Java frameworks and provides some task to build a container image, generating those manifests so you don't have to write your YAML files, and then apply the manifest to a Kubernetes cluster. And it even has this very nice command to watch your application for changes, so we can once again establish that continuous development loop. But I want to use Cloud Native Buildpacks, for example, and Buildpacks is not supported in here. And also, we have all these great frameworks that provide a lot of amazing integration and developer tools. So I want to look for something that lets me rely and take advantage of the underlying framework that I'm using. And in that regard, I like using Tilt. Now, with Tilt, we can really automate all this process, because if we think about how we work as developers, we start by making some code changes, then we build a container image, we run that container image on Kubernetes, and finally we do some testing, debugging, and this all starts over. It's what we call an inner development loop. So everything that happens before we deliver our code changes to the Git repository. So using the tools I mentioned so far, with Tilt we can automate the whole process. So what I can do, I have a Tilt configuration file. I can say Tilt up, just like Docker Compose up. In this case, it's Tilt up. And what Tilt does is going through the commands that I ran so far manually. So I'm using the Cloud Native Buildpacks integration in Spring Boot. And here I can put the command from whatever framework I'm using here. So we don't need additional tools. We can rely on the power that is brought out of the box by our framework. I'm using the manifest that I defined earlier to apply to the cluster, exposing the application to my local host so I can use it as if it was running locally. And then the cool thing is that I can configure this live reload. So the combination of Buildpacks and Tilt allows to have this live reload so that instead of rebuilding the container image every time that you make a change, simply if there's a class that changed in your application, it's only that file that is transferred inside the existing container image. And then the process is reloaded. So it's quite convenient and lets us achieve this very fast feedback loop. And Tilt also has a very nice GUI, so you can follow all the steps. We can see from the beginning that it's running Cloud Native Buildpacks from Gradle, so it will build the image, and then it will deploy the application. Every time it detects changes, it will reload it. And finally, it's exposed through localhost 8080. So we added all this complexity, but we managed somehow to hide it behind Tilt. So now I have one command to start my continuous development loop. Let's say that it's fine for now. I think it's still not good enough, but let's pause there. So we established or tried to improve things after introducing all that additional complexity. We finally implemented our solution. We solved the problem. What happens next? We need to push our changes. And now, depending on your organization, you might do continuous integration and push directly to the main branch, or perhaps you're using pull request, and your process requires that someone manually has to approve the pull request or test some new functionality in the pull request. So if that's the case, we can automate that on top of Kubernetes as well, so that we can use the same steps, but to establish these temporary environments that are related to pull request. And we can do that with Argo. Now, Argo is usually used in what is called well, not in the inner development loop. It's part of the CI/CD pipeline to do continuous deployment, but Argo can do much more than that, because we can configure it so that once, as a developer, I push my changes, I create a pull request, then Argo can detect that in my Git repo, there's a new pull request opened, and then it will provision a temporary environment on Kubernetes and synchronize my changes. That will happen automatically. It will keep it in sync if I update my pull request. And once the pull request is merged or closed, then ArgoCD will shut down the temporary environment and clean up all the resources, which is quite convenient. Let's see how it works. So I need to switch to a different cluster now. All right. And expose Argo. So Argo has a nice GUI like this. All right, so we can see there's no application in the cluster now. And I have configured Argo to monitor my music service Git repository on GitHub. So now I can go ahead and make some changes. Just to make it simple, I'll make some changes in the README file. Hello, Devox. And then I'll create a pull request with these changes in a new branch called Devox. I open a pull request, create pull request. So now, like, my fellow developers can check the code, but also I get an environment automatically provisioned to check the GUI. So you can see this popped up just now. So it's now deploying my music service application from my pull request branch. In a few seconds, it will be done, and I'll be able to test it manually. Once the pull request is approved, then this will go away. So we can see that if I close the pull request, like that, or merged, now it's unprovisioning my temporary environment. And I think this is really cool, because as a developer, I don't want to also go through manual steps in order to prepare an environment, perhaps for a tester, to verify maybe the user experience of my new changes to my application. All right. Now let's say we deliver the pull request, all is fine, but still I'm not quite happy based on the goals that we established at the beginning. Because even if we have a lot of automation options, I think it's really important to consider where is all these tools, all this complexity placed. Is it on the developer side, or is it on someone else's shoulders? And based on that also, do we want developers to work directly with Kubernetes or not? Because if we don't want, as a developer, like if I don't want to work directly with Kubernetes, there are tools that allow to work locally. For example, Telepresence, that basically creates a bridge between your local computer to a cluster running remotely. And you don't need to know about Kubernetes. I run my Java application as I usually do locally. And under the hood, there is this process that proxies request incoming and outgoing to the rest of the cluster. So I can just work locally on Java. I don't need to install Docker. I don't need to install Kubernetes, nothing. And Telepresence takes care of that. Dinner Brian here says that this tool seamlessly extends your laptop into a Kubernetes cluster, enabling you to interact with remote services as if they were local, which is quite handy in general as a development strategy when working with Kubernetes services, but also as an additional tool in your toolbox when you need to troubleshoot some services on a cluster and you don't want to interfere with what is running on the cluster. You start this telepresence communication, and then you can work locally. And the traffic is proxied through your local host automatically, which is really nice. But if we really do want to work with Kubernetes, then we need to be careful, because we have all that additional cognitive load that doesn't go away just because we automate things. Because if stuff doesn't work on my tilt configuration, for example, it's still me as a developer being responsible for how it's containerized or how the Kubernetes manifests are generated. So we need something else. And the trick there is that as a developer, I don't get access to Kubernetes directly. But there's a platform team that provides services on top of Kubernetes in a self-service manner, and I get a curated experience on top of Kubernetes. And that's why I mentioned several times tools are not enough. We need also the right organization in place, because if every development team needs to take care of their own Kubernetes, things will not work things will not scale, and as an organization, you won't see the benefits that you were expecting to get by going through this cloud native transformation and using Kubernetes. So we need the right organization in place, and we also need the right processes. Like, what is the developer responsible for, and what is the platform team responsible for? Like Kubernetes, for example, probably it shouldn't be the developer being responsible for that. So we need to go through a few iterations in order to improve the developer experience based on this approach. And we can start investigating even more tools. For example, I really like Knative. Knative provides a serverless experience on top of Kubernetes. I really like what Kelsey Hightower wrote a few years ago. If Kubernetes is the electrical grid, then Knative is its light switch. If I want to turn on the light, I want to operate the light switch. I don't care about the electrical grid underlying. So as a developer, I also want to deploy my application, but I don't want to know about the underlying machinery that runs with Kubernetes. This is an important factor. And Knative offers a great developer experience. Overall, the idea is to have developers focus on the code, focus on the business logic. Instead, the platform should take care of the rest, should take care of provisioning infrastructure, of managing the workloads, and on dynamically scaling everything that we might need there. So just to give you an example, Knative has a convenient CLI, so I can say kn service create, and then the name of the service, book service, or we were talking about the music service, so let's use that. And then I pass an image. And I should check that I'm in the right cluster. Yes. OK. So by running this command, Knative will generate an abstraction on top of Kubernetes. It's called the Knative service. And the only parameters I need to provide are basically my image. Not even the port number, because I'm using defaults. So even less information than what I would use with the Docker CLI, because with the Docker CLI, I specify image and port number. With Knative, I can even just do with the image. And then I get back a URL, even with HTTPS, and I can verify that my application is working. And it's working, it's secure, perfect. So that's better. And now we could continue, I could continue to present a lot of different tools. Like, it would be a never-ending presentation, to be honest. But I don't want to do that, because overall, what I want to achieve is capabilities over responsibilities. They're all nice tools, they're all great, but as a developer, I like to take advantage of those capabilities, but I don't want the responsibilities. Like, I want to be responsible for my own application. I want to know about the framework I'm using, about Java, but I don't want and I don't need to know all the stuff that goes on with Kubernetes. So if we have all these tools, and I could present even more, what I want to do is, instead of having them all piled up on the developer side, which leads to probably a failing Kubernetes strategy, because at some point this doesn't scale. It's impossible to know all the details about the whole stack, from the application down to Kubernetes and down to the network even. And I want to get rid of all of them, perhaps leave one, like Tilt, or a similar tool like Scaffold, just one, where I can run my initial command to establish this continuous iteration loop. And then I want to move all the tools down to the platform. And then it's someone else's job to work with that, because we have experienced people with great skills in working with Kubernetes and with cloud native technologies. So there's no need for me as a developer to know about that. I think it's important to have those tools, because they're really great. They solve problems that we commonly have. But it's important that it's not the developer using them directly. Of course, as a developer, I need to know the constraints of the environments where I'm building my application. But that's true in any case, not just for Kubernetes, right? But then as a developer, I want to get all those services kind of transparently. Someone else is managing them, is patching them, ensuring security, ensuring performance, ensuring availability. They can be all grouped together. So the platform engineers inside the platform team can curate an experience, combining all these tools together, all these capabilities. And then we need an access point. We need some API to call the platform. And that's probably the only other thing I need to know. I have Tilt or similar tool to start my developer workflow, and then I need a way to call the platform to take advantages of all those capabilities. And now an example of that I'm going to present is Cartographer. Now, Cartographer is defined as a Kubernetes native choreographer. I like to define it as a framework to build paved path to production. So platform engineers can use Cartographer to establish this path to production that takes into consideration not only the development workflow, but also the whole CI/CD pipelines, all together on top of Kubernetes. But the important thing is that ultimately, developers don't need to know about anything except what the developers know that the platform doesn't. So what's that? The name of the application, the Git repository where we have our application deployed, maybe the branch name, and optionally some metadata, like what type of application is. Is it a web application? Is it a batch application? And Cartographer exposes a workload API. So this is all I need to know as a developer. I specify the name of my application, for example, band service. I specify the type, web. I specify the URL and the branch. That's it. So now I can combine these two things. I have Tilt that I can use to establish this live reload loop. But Tilt will not take care of containerizing or deploying my applications, because it will use Cartographer, or it will use this API to tell the platform, please start the whole development workflow. So as a developer, I only need to know about these two things. Let's see how it works. I have the same application as before, but this time I have added a new file. It's this workload specification, where I have additional metadata about the application, that is a web application in Java, my Git URL, and subpath. And now, I need to switch again to the right cluster. Yes. All right, now I can say tilt up. But now tilt is simply using this resource to request from the platform all those services. So the platform will take care of using Cloud Native Buildpacks to containerize my application. It will generate all the manifest, all the configuration, and deploy my application. So we can see from here that nothing else is happening except I'm using Cartographer to make that request under the hood. But then, if we look at what is going on, no, it was book service. So many services. So we can see that there's a few activities that are going on here. So the platform is getting my source code, is containerizing it, is applying all conventions. So my platform realizes that, oh, you're using Spring Boot, then I'll auto-configure actuator endpoints, Prometheus endpoints, graceful shutdown. It will generate all those Kubernetes manifests for me, and finally will deploy my application. Then again, I'm using Knative, so I get this nice URL I can call with HTTPS, and welcome to book service. And now I can make changes to my application, and Tilt will reload them as it did before. But now I don't have responsibilities for any of those tools. Like, I'm just getting the capabilities. And then under the hood, a lot of things can happen. But it's important that when we talk about delivering value, we consider other roles in the organization that need to be involved. Application operators, security experts, platform engineers. Because the tendency sometimes is to try to do everything on the developer side, try to use all these tools, combine as much as possible so that everything then is stored together with the application source code. But that means that all these other personas here will not have a chance to collaborate. So what happens if, for example, there's a security vulnerability? A few months ago, there was this OpenSSL vulnerability affecting Ubuntu images. Who is responsible for patching that and for doing it very fast, or as fast as possible? If every developer team has their own configuration, has their own stacks, then it will become a very slow process, ensuring that all the applications within an organization are patched. Instead, if you centralize all these concerns inside the platform and have a centralized team that takes care of that, in one single point, you can patch the base image that is used to build a containerized application, and then automatically all applications that are using the platform will get the patched version. That's also really important to consider, because sometimes it's easy to get caught up in all these tools and trying to improve the developer experience by adding even more tools on the developer side. But ultimately, especially if you're working at scale across multiple teams in your organization, we really need to have this centralized place providing all these services where security is centralized, where compliance is centralized even. And then what happens under the hood is really someone else's responsibility. So all those tools can be used to establish how we test stuff, how we build it, how we configure it, how we deploy it. But then again, as a developer, I just have that workload API that I like because it's simple. It's still YAML. Maybe we can do something about it. Actually, there's a CLI we can use if we don't like YAML. But at least it's limited to a couple of information that I know, like Git repo and name of the application, right? So we achieved a rapid and continuous feedback loop. We saw that we can do it without the platform. We have enough tools that we can use in our development environment. That's fine. But if we move all of those responsibilities down to the platform and just take advantage of those capabilities, then we also be able to reduce the cognitive load, which is an important factor. And then ultimately, if we rely on a platform that takes care of the whole journey, the whole path to production, including the developer environment, then we also achieve the third goal. Because we need to consider all the activities we do locally on a developer environment as part of the bigger picture. Because the way we containerize, the way we deploy locally, it should be the same that we do in test environment, the same we do in production. We want to have environment parity everywhere and have all of these as streamlined as possible. Now, there's still something that I don't like, though. I mean, we achieved the goals, right? But I started my experience, if you remember the baseline, I went to Spring Initializer or the equivalent in other frameworks. I bootstrapped my project, and then I ran a command. But now if I do this, I initialize my project, and then I need to configure tilt, additional step. I need to configure the workload specification, additional step. And then finally, I can run the command that lets me focus on the code. So I think there's still room for improvement. Let's give it a try. So I'm using Backstage, yet another tool, right? So the platform could provide interfaces via CLI, via APIs, but an important part of a good platform from a developer experience point of view is providing a portal that gives access to all those capabilities, all those tools, but in an abstracted way. So from this portal, I can do a lot of different things, but the thing I'm interested in right now is that I can bootstrap a new project. Let's see what's happening here. So from here, I have access to a series of templates from which I can bootstrap new projects. If it loads. Yes. So I can choose one of the templates that are pre-configured for me as a developer to use directly. For example, if I want to build a Spring Boot reactive application, I can choose this template. It's also what is called a golden path. I provide some information, for example, demo Backstage, the package name, demo, maybe I'm in team A in this example, and then I specify information for my GitHub. So from here, I can bootstrap a project. I can create automatically the repository on GitHub. Let's give it a second. It will publish all the code on GitHub. Let's check it out. So I have my application here, and it's what I would get from Spring Initializer directly, but now I also get additional configuration for tilt. I have this tilt file with configuration about how to use the platform, and then I have the workload API. So I can automatically get that. I don't even need to write that. So the second operation after bootstrapping the project is actually doing a git clone and check out the code. And after that, I can say tilt up, and then I start. Now I have another tilt process running, but I do tilt up, and then my application starts on the cluster. I get my live reload capabilities, and only works like before. So now I'm happier, I would say. All right. So just to recap, we have a lot of different tools we can use to improve the developer experience on Kubernetes. It's important to make it part of a bigger strategy in the organization and consider also the processes that we use to work with Kubernetes and the type of organization around it. It's important not to make the mistake of using Kubernetes when we don't need it, because, I mean, it's undeniable. It adds more complexity. So if we have the problems that Kubernetes tries to solve, that additional complexity is justifiable. But if we don't need it, then let's do something else. And then even if we decide to use Kubernetes, it's important to establish very clearly this separation of concerns between developers and a platform team. So what is the developer supposed to know and to be responsible for? I leave you with some resources. There's all the source code is on GitHub, some additional documentation. Thank you very much for joining. We have some time for questions. If you have any, have a great rest of the conference, and see you next time.
Hi, cheers for the talk. I've got a question that kind of relates to how you see this scaling over time, because on projects that I've been in the past, specifically quite recently in the last 2 or 3 years, where DevX and Golden Paths has been quite a big thing, we've kind of done quite a lot of this stuff, if not most of it. We've just swapped different tools out. So instead of Argo, we've had FluxCD, and et cetera, et cetera. So we've kind of achieved the same things. But the problem we have over time that we see, specifically when it scales into the hundreds of services, is over time when the archetype, you could say, for templates change. So if you have a Spring reactive template, for example, with a tilt file inside it or a Docker file inside it, over time these will change. How do you see the I guess staying away from tools at this point, but how do you see ways of actually maintaining that things still align with the root archetype for templates? So if the Spring reactive template was to change in any way whatsoever, if they were to update a tilt file or a Docker file, how would that then, would you see, get propagated down to the services that were created from that original template that was a previous version? Because otherwise, the way we see it at the minute is that has to be a change that's applied across multiple repos when that change gets introduced. I'm just wondering what you think, how that scales.
Yeah, that's an important thing to consider. So we have all these templates, but once we use them to generate stuff, then they're kind of fire and forget. Like we know that was the template originally used, but it's important to work with those templates like we do for normal source code applications, like having it versioned and clearly or paying attention to how we version it, and then define also some migration path. So I imagine some, again, tools or a way to help developers then to migrate a project based on the new template. So if we have versioning, for example, using semantic versioning, if it's just a patch or a minor change, then it should be an easy thing to do. But if it's a major change, then some additional tooling might help. Again, more tools, right? But yeah, it's something to consider. And I think that's important. That's why it's important to place these tools in the right location. Because let's say that as part of the template, I also have Docker files, I also have Kubernetes manifest. How do I make sure that they get updated? So pushing them down to the platform makes it possible to change them without affecting the application. But no matter what, we're still going to have a couple of things that we need to change, like a workload API or something similar in other platforms that we need to version. But my suggestion would be to reduce as much as possible that part that might vary based on something external to the application team. So just keep the API as small as possible, as customized as possible, so that changes will not affect or will not have a big impact on the application teams. I hope I answered the question. Yes? So once again, thank you very much. If there's no more questions, I wish you a great day.